You know that quote from Frank Lloyd Wright? A doctor can bury his mistakes, but an architect can only advise his clients to plant vines.
He wasn't wrong, was he? Especially in software, the
Oh,
mistakes are, well, they're very visible.
exactly. And that visibility is why we're doing this deep dive today. We're looking at software architecture evaluation, basically, the essential insurance policy you need before you build anything complex.
That's a great way to put it. Evaluation is really the only structured way we have to um, de-risk the whole process before you start coding.
De-risk.
Yeah, it's about figuring out if the design you have is actually fit for purpose. Can it meet those critical quality goals like performance, security, whatever they might be, before you've spent a fortune building it?
Okay, so that's our mission then, to really unpack the concepts, the methods people use to scrutinize an architecture. And, crucially, always looking at that cost-benefit thing, right?
Absolutely. The value you get has to outweigh the cost of doing the evaluation itself. It's fundamentally an economic decision.
So, evaluation as risk reduction.
Yeah.
How do we define risk here?
Well, in this context, risk is basically an event that has both an impact, like how bad is it if this goes wrong, and a probability, how likely is it to go wrong.
Right.
And the potential cost is, roughly the probability times the cost of that impact.
Okay, that makes sense. So the scale matters hugely.
Immensely. Think about it. A safety critical system, maybe controlling aircraft or medical devices,
Mm.
we're talking millions, maybe billions at stake. The impact of failure is catastrophic.
So you absolutely must evaluate rigorously there, maybe using something formal like ATAM, which we'll get into.
Exactly. Now contrast that with, say, a small update to a console game. Maybe it costs tens of thousands.
Yeah.
The impact if something goes wrong. Annoying, maybe some lost players, but
Not billions of dollars down the drain.
precisely. So a much lighter evaluation, maybe just a peer review, makes more economic sense.
And what about the probability side? Does experience play a role?
Oh, absolutely. If your team has built similar systems dozens of times, the probability of a major architectural flaw is, probably lower. But if it's a brand new type of system for the organization, maybe using unfamiliar tech, solving a novel problem, the probability of getting the architecture wrong goes way up.
Which makes evaluation much more critical in those cases.
Definitely. But regardless of the scale or the method, evaluations always kind of circle back to the same core ideas. Understanding the business goals, defining those quality attribute scenarios, QAS, and then seeing how the chosen tactics and patterns actually support them.
Got it. So the drivers are those architecturally significant requirements, the ASRs, expressed as these QAS. That's what you focus on.
That's the heart of it. And you can do these evaluations really anytime you have an architecture candidate that's coherent enough to actually review.
Okay. You mentioned core activities, sort of universal steps.
Yeah, basically 4 things that every evaluation needs, no matter how big or small. First, the reviewers have to get their heads around the architecture. Immersion, you could call it.
How do they do that? Documentation.
Usually, yeah, documentation, maybe a presentation by the architect, whatever it takes, so they actually understand what they're looking at.
Makes sense. Step 1. Understand the thing. What's next?
Step 2 is figuring out the drivers. What are the high priority quality attribute scenarios? What absolutely must this architecture achieve?
Okay, focus on what matters most.
Then, step 3 is the real analysis, the deep dive. For each key scenario, the reviewers, often guided by the architect, walk through the design. Does it actually satisfy the scenario?
So like tracing the scenario through the component.
Exactly.
Yeah.
But, and this is really crucial, they don't just stop there. They also look for negative interactions. Did a decision made to boost performance accidentally create a security hole?
The unintended consequences.
That's it. Finding those interactions, those trade-offs, is where a lot of the value comes from.
Okay, so understand, prioritize, analyze for satisfaction and side effects. What's the last step?
Capture the problems.
Uh-huh.
Any potential issues, risks, or concerns found during the analysis need to be documented clearly.
And that becomes the action list.
Pretty much. It's the basis for follow-up. Either you decide to fix the problem, or the decision makers have to look at it and say, okay, we understand this risk and we consciously accept it. No burying your head in the sand.
Right, which brings up the question, how much analysis is enough? Do you need to analyze every single possibility?
Good question. No, definitely not. It comes back to that economic balance. You need to consider how important the decision is. Are you choosing between 2 fundamentally different approaches or just minor variations?
Okay.
How many alternatives are really on the table? And sometimes you just need good enough, right? If spending another week analyzing isn't likely to lead to a drastically better outcome, it might be better to just choose and move on. Perfection can be the enemy of progress sometimes.
Okay, so who actually does this evaluating? Is it always the architect?
It can be. The architect is doing a form of evaluation constantly, right?
Right.
Every time they choose a pattern, make a design decision, they're weighing alternatives. That's the first group. The
Yeah.
architect themselves doing ongoing evaluation.
Part of the job. Base pick.
Exactly. Then the second group is peer review. This is more formal, but still internal. Maybe a few hours, half a day, often at the end of a design phase, like after an attribute-driven design iteration.
So, colleagues looking over the work.
Yeah. You get quick feedback, leverage internal knowledge. You might use something like tactics-based questionnaires, which we can talk about.
Okay, architect, peers.
Mhm.
Who's the third group?
The outsiders,
Right.
bringing in external experts.
The hired guns.
Kind of, yeah. They bring objectivity. They aren't tied to the internal culture, the we've always done it this way thinking.
That can be valuable.
Very. Plus, they might have specialized knowledge the internal team lacks. And let's be honest, sometimes management listens a bit more closely when they're paying consultants a lot of money to find problems.
Sad but true sometimes. So for these more formal external reviews, you need a defined process.
Definitely. For repeatability, for stakeholder buy-in, you need structure. That's where methods like the architecture trade-off analysis method, ATAM, come in for those big external reviews. And for internal peer review, maybe something like lightweight architecture evaluation or LAE.
Let's dig into ATAM first. You said it's the gold standard for external evaluation.
It really is. Developed over decades, used on massive, complex systems. A key thing is the evaluation team doesn't need to know the system beforehand, and it can be done before a single line of code is written.
Impressive. Who needs to be involved in an ATAM?
3 core groups are mandatory. First, the evaluation team itself, usually 3 to 5 external, unbiased experts. They have specific roles, like a team lead, someone focused on leading the analysis, scribes for scenarios and general documentation, maybe a dedicated questioner.
Okay, the expert reviewers.
Second, the project decision makers. This includes the project manager, maybe a customer representative, and crucially, the architect. The architect has to be a willing and active participant for it to work.
Right, they hold the knowledge. And the third group?
The stakeholders. Anyone with a vested interest. Users, developers who will build it, maintainers who will support it, testers.
A broad group?
Can be. For a large system, you might have 10, 15, even 25 stakeholders. Their job is to articulate the quality attribute goals that really matter from their perspective. What does performance mean to a user versus a system admin?
Getting those different perspectives is key.
Absolutely. The power of ATAM is how it connects the technical details back to these business and stakeholder goals.
How does it start? Does the architect just dump all the documents on the team?
No, it's more structured. One of the early critical steps is the architect presenting the architecture. Concisely, clearly, using standard views, maybe component and connector, module decomposition, deployment views, enough for the evaluation team to get that necessary understanding, that immersion we talked about.
Okay, get everyone up to speed, then what?
Yeah.
You mentioned something about a utility tree.
Yes. Step 5, generating the quality attribute utility tree. This is maybe the most powerful part. You take broad goals, like the system needs to be modifiable, which is vague.
Right, what does that even mean?
Exactly. The utility tree forces you to break it down into specific, concrete scenarios. Like, a developer should be able to add a new payment gateway type within 2 weeks. That's measurable.
Okay, concrete scenarios. Who comes up with those?
It's a brainstorming activity involving stakeholders, the architect, the evaluation team. Then the decision makers rate each scenario on its business importance, high, medium, low. And the architect rates the technical difficulty or risk involved in achieving it, also high, medium, low.
I see. So you get this matrix showing what's important to the business versus what's hard technically.
Precisely. It immediately highlights the most critical areas to focus the analysis on the high importance, high difficulty scenarios.
Smart. So you use that tree to guide the analysis phase.
Exactly.
Okay.
Steps 6 through 8 are all about analyzing the architectural approaches against those high priority scenarios. The evaluation team probes, asks questions. How does this design choice support this specific scenario?
And this is where those sensitivity and trade-off points come in.
Yes. A sensitivity point is an architectural decision, like the choice of a specific algorithm, or the number of servers that has a really significant impact on a particular quality attribute. Change that decision, and the response changes dramatically.
Okay, a critical knob to turn.
And a trade-off point is a decision that affects multiple quality attributes, but in opposing ways.
Like the example you gave earlier, heartbeats for availability versus performance.
Perfect example. Increasing heartbeat frequency improves availability. You detect failures faster. That's good. But it consumes more network bandwidth and CPU cycles, hurting performance. That's bad. That decision point is a trade-off. ATAM is designed to explicitly find and document these.
So what comes out at the end of an ATAM? A big report.
You get several key outputs: a prioritized list of those quality attribute scenarios from the utility tree, detailed analysis of the architectural approaches, a list of identified risks, non-risks, things that were checked and found okay, sensitivity points, and trade-off points.
That sounds comprehensive.
It is. But arguably the most important output, especially for management, is the set of risk themes identified in Step 9.
Risk themes. What are those?
These aren't just individual risks, but overarching patterns of weakness in the architecture. Maybe there's a theme around inconsistent error handling across different subsystems, or a lack of a coherent data persistence strategy.
Ah, systemic issues.
Exactly. And the key is that these themes are explicitly linked back to the business goals identified earlier. When you tell a manager, this architectural weakness directly threatens our goal of launching by Q3, that gets attention.
Connecting the tech to the business impact.
That's the goal. And beyond the documents, ADAM often creates better communication, a shared understanding of the real challenges and strengths. It builds a kind of community around the architecture.
Okay, so ANTAM is the heavyweight champion. What about the lighter options? You mentioned LAE.
Right, lightweight architecture evaluation. This is designed for internal teams, for more regular check-ins. Think peer review. It's much less formal, maybe takes a few hours to a day.
Less ceremony, faster turnaround.
Exactly. A key difference is that LAE often focuses just on the changes made since the last review. What's new? What risks might that have introduced? You trade off some of that external objectivity you get with ATAM, but you gain speed and lower cost, which helps keep the project moving.
Makes sense for iterative development. And even lighter than LAE.
Tactics-based questionnaires. These are super focused. You pick one quality attribute, just security or just performance, for instance, and use a predefined set of questions based on known architectural tactics for that attribute.
How long would that take?
Maybe an hour per attribute. It's really quick. The questions guide the reviewer, often the architect themselves, or a peer, to check if relevant tactics have been considered and applied correctly.
Is it effective, being that fast?
Surprisingly so, for finding specific types of problems. There was a great example with a system handling healthcare data. The requirement was don't send data in the clear.
Okay, encrypted.
Right. The architect used simple XOR encryption. Technically, it met the requirement the data wasn't in the clear.
But XOR is notoriously weak.
Bingo. The security tactics questionnaire would immediately raise flags. What encryption algorithm is used? Is it industry standard? Is key management handled properly? It would instantly highlight that using XOR, while technically compliant with the letter of the requirement, introduced a massive actual security risk because it's so easy to break.
Wow. Found quickly and cheaply using a simple questionnaire.
Exactly. Shows the power of even very lightweight focused evaluation.
Okay, so recapping this whole area, evaluation is fundamentally about quality assurance, but done predictively before you build.
Yes, identifying risks early when they're cheaper to fix.
And there's a whole spectrum of methods. At one end, you have the rigorous external ATAM, great for huge, risky projects, producing those systemic risk themes linked to business goals. Then in the middle, the internal faster LAE for regular peer reviews, focusing on changes.
Right, lower cost, maintains velocity.
And at the other end, these super fast tactics-based questionnaires for checking specific quality attributes really quickly.
Spot checks, basically. Highly effective for certain kinds of risks.
But the underlying goal is always the same, isn't it?
Always. It's about drawing a clear line from a specific architectural decision, a pattern, a tactic, a component choice, to its impact on the critical quality requirements and ultimately on the business goals. Are we building the right thing? And are we building it the right way to succeed?
But that connection is vital. So a final thought for our listeners. We talked about how evaluation often uncovers mismatches between what the architect thinks stakeholders want and what they actually need.
That happens all the time.
So thinking about your next project, how could you maybe borrow some ideas from ATAM, even if you don't do the full process? Like using that utility tree concept or the scenario brainstorming. Getting stakeholders to really articulate what success looks like to them specifically and measurably before you even finalize the architecture.
Using that tension between business importance and technical difficulty ratings to force alignment early.
Exactly. Imagine getting everyone on the same page about what success truly means right at the start. That could save a lot of pain later on.